today we're going to have a look at another chapter. It's from the Business Management Toolkit unit, and it's going to be about the tool called Decision Trees. Okay, let's get started. So in this unit, we're going to look at the planning tool Decision Tree and try to see how we can use it in a given situation. Then we're also going to have a look at how what value it brings to the organization. And we're going to try to construct a decision tree by ourselves. So why is planning in general, why is it important? What do you think? Yeah, so talking or thinking about objectives, business objectives, when we have that, why might we want to plan how we're going to achieve them? Planning is important so that we can manage our projects as effectively as possible, so that we can achieve those business objectives as efficiently as possible. We can do that through different projects, but in order to understand that, why planning is important, we need to know what are projects, how can we define them. So projects have a start and an end. They have specific tasks defined. They have very clear goals, so it's absolutely obvious what are the success criteria. And to complete the project, you need some resources. So how does that link back to some of the chapters that we've studied? We know that every organization has its objectives, and there are different ways how it can achieve those objectives. Most of the time, it does that through different projects. And as you can see, each of the projects have to have their own criteria, but overall, the organization's job is to make sure that the projects are leading us towards that one goal, towards our mission. So project, if we were to write a definition, it's a specific and temporary activity with a start and an end date, clear goals, defined responsibilities, and a budget. Okay, so project could be your internal assessment for business management. It could be, for example, your CAS project. It is all, these different projects are all leading you to the successful finish of the IB diploma studies or the IB diploma program, but you can consider them as specific projects. Examples of business projects, it could be marketing products in another country. It can be, for example, also building a factory. Okay, it has a start date and end date. Once it's built, the factory, then you can use it, but the actual project of building it is finished. So most of the time, businesses actually have more projects going on at the same time, and it's good to have those projects and also good to know how they're leading you to your final goal. All organizations need to plan. So what is it that we're planning? There are 4 basic elements for any project that need to be managed simultaneously. Simultaneously means at the same time. What do you think they could be? So here you have some kind of icons. What do you think each of the icon represents? So the first, I don't know, the yellow one, the green one is obvious, but what could the blue one represent? Blue one means resources, and here we can put anything from people to equipment to materials. Okay, we need to manage our resources, and obviously we need to manage our time, the time that we need for each activity, and also the time that we need for the whole project. Then money, obviously the budget is going to be affecting our resources. It's going to affect, for example, the time that we need for the project. So all of these elements are interconnected. And obviously we need to follow the budget. Once we plan, we need to follow the budget to make sure that we achieve the expected profit that our project is profitable. And then the last element is scope. We need to be establishing the overall size of the project. We need to know how big do we want the project to be. And depending on the scope, we set specific objectives. Okay, remember that all the good objectives need to be smart, so they need to be specific, measurable, achievable, relevant, and time specific. This applies for projects as well. And basically, all of these elements, if you basically put them all in a definition, this is going to define the term organizational planning. So what is organizational planning? It is the process of identifying an organization's immediate, so some short term, as well as long-term objectives. Now, once you have the long-term objectives, then you formulate and monitor specific strategies to achieve them. And it also involves employee and resource allocation to allow for the effective completion of the projects. So really, again, it's putting all of the different, let's say, information that we've learned in the in the objectives in 1.3 unit, talking about business objectives. You see, once you have the objectives, you pick the strategies, and then once you have the strategies, you already decide about the allocation of your resources and basically plan for the project. So looking at decision tree. Now, before I start explaining what it is, I actually wanted to show you what it looks like, because a lot of the things can be read about the decision tree or from the decision tree before you actually know anything from it. Okay, so look at the picture and I want you to answer for yourself, what do you notice about it? What is the purpose of it? All right, so as you can see, we have a decision tree for the fundraising auction. So it's somehow helping us decide something about the fundraising auction. And you can see that there is some kind of point here, starting point, and then there are two branches coming out. One is called indoors, one is called outdoors. So that is already perhaps hinting that the decision is about where the fundraising auction is going to happen. Is it going to happen indoors or is it going to be happening outdoors? Now you see also some number here in dollars, and it's put in brackets. Usually when we have something in brackets, it's actually, business management means it's a minus. So this will actually be the cost. How much does it cost to create a fundraising auction indoors? How much does it cost to create a fundraising auction outdoors? Then, as you can see, it leads us to some kind of circle. And from that circle, we have some other branches coming out. One says fine, one says poor, again, fine, poor. So maybe it's not clear, like from the actual wording here, but I'm going to basically help you or tell you that it's referring to the weather. So in this branch, it says that, or here it's talking about the weather being fine, and if the weather is fine and it's happening indoors, you have here some kind of money. And if the weather is poor and it's happening indoors, the money here is bigger. Why is that? Perhaps. What do you think? And then also, like, what does this money represent? This is actually, I'm going to tell you, this is actually the expected return. So how much, or economic return. So how much am I expecting to gain from an auction from the auction if it's happening indoors, but the weather outside is nice. So here we are actually going to be getting less. And then these numbers, 0.6, 0.4, what do you think they could be? They could represent. Here again, on the bottom one, there's 0.6, 0.4. Why is it like that? It adds up to 1. It's actually going to be talking about the probability. So what is the probability of fine weather happening? So there's 60% probability of there being fine weather. There's 40% probability of there being poor weather. So the decision tree, I mean, it's once you perhaps know the case study, what it's talking about. So here it's talking about a fundraising auction, sorry. The different information that is listed here, it's quite it has some kind of structure. It is quite you know clear what we mean by the different words or by the different numbers, and it's very easy in the end. Once you learn the technique, it's very easy to read. So what does a decision tree do? What is its purpose? So it's considering the value of the options available to us or to the business, and it considers the chances of these options occurring. Okay, we use it, or the manager uses it to show all the or see all the options that are available. The decision tree shows us the different possible outcomes resulting from these options. So before, as we could see, the outcomes were the money raised, the chances of these outcomes occurring, and the economic return from these outcomes. The definition is the diagram that sets out the options connected with the decision and the outcomes and the economic returns that may result. Now, I'm going to read that again, but I'm going to read that together with the diagram. The decision tree is showing you the options. So here are the options connected with the decision and the outcomes. So the outcomes would be fine weather, poor weather, and it also shows you the chances of the outcomes appearing or occurring, and the economic results that may result from the different decisions and the different outcomes. So how do we, let's say, use the decision trees? It helps us compare the likely financial results from each option. And then once we have the likely financial results of each option, the manager can actually pick the one where you have the minimum risk and the maximum return. Now, how do we do that? We need to actually know how the decision tree is constructed. So first of all, it's constructed always from left to right. Yeah, so you start here and you go that way. Each branch equals an option with a range of consequences. So here is one option, and then we have consequences. The squares actually represent decision points. So this is the moment where the business is making some kind of decision. This is my decision node. I'm making a decision of whether I want to have my auction indoors or whether I want it to happen outdoors. Then what we have circles. The circles actually are chance nodes. Okay, they are showing the range of outcomes, but these outcomes we already cannot pick. I mean, we cannot decide. The only thing we can do is actually list them and predict the chances of them occurring. For that, we use probability. So here, this is actually the probability, and that's why it's adding to 1. So the probability of fine weather is 60%. The probability of poor weather is 40%. So the probabilities are shown to measure the chance of an event happening. So the chance of there being fine weather is 60%. And the last thing, the last part is economic returns. Shows you the expected financial gains, or in some cases losses, but here, since the numbers are positive, here it's all showing us the financial gains from the different decisions and the different outcomes. So once the manager plots all these options, I mean, how you basically work is you read some case study, read what is going on, read the information, then you construct the decision tree. But then your work does not stop there. As a manager, you need to be able to read the decision tree and somehow calculate the best option. So once the manager plots all the options, possible outcomes, probabilities, and economic returns, he needs to calculate the expected value. Now, what do we mean by expected value? It is the likely financial result of an outcome obtained by multiplying the probability of an event occurring by the forecast economic return if it does occur. Now, don't worry, at this moment, the definition is maybe a little too long, a little too complicated. I'm going to break it down again so that you can understand better. To calculate expected value, we now work with the decision tree, but we now work with it from right to left. Okay, so before, when we were constructing the decision tree, we were going from left to right, but when we want to read and calculate the expected value, we need to work from right to left. So let's get to it. Here is the same decision tree, but here are already some calculations. So I'm going to show you how we work from right to left. You take the possible economic return, which is, for example, in this case, 5,000. Here it's 7,000, 10,000, $4,000. And you multiply it by the probability of this economic return happening. So 5,000 times 0.6, 7,000 by times 0.4, and so on. Then what you do? You write down the result. Okay, so here, actually this can be read like split. This branch is going to have 3,000 written here. This branch has $2,800, 6,000, 1,600. What you need to do is actually, once you get to the chance node, to add these two values together. So that's how you get 5,800. The expected value at each chance node is calculated by adding the results. So the expected value, this is the expected value of the indoors decision. The expected value of the indoors decision is 5,800 because we added the 3,000 and the 2,800. The expected value of the outdoors option would be 7,600 because we add 6,000 and 1,600. And then what do? We subtract the cost of each option. So here we see the indoors option costs 2,000 to create. And if we subtract that from the expected value, we actually find the net return. So the net return of the indoors option is 3,800. Now the net return of the outdoors option is 4,600. So which one is actually best option to pick? Well, you're going to pick the option that has higher net return. Yes, on one hand, it has higher costs, but then also the expected values, the expected returns are higher. So the net return is also higher. And what you do is you actually cross out two times, two lines. You cross the option that you are not choosing. If there are more options that you're not choosing, you cross out all the other options. So there is going to be only one way that is sort of the free way that you're choosing. So, and again, with the arrows, you have here specified what do we mean by the different words. So here we see the expected value, here we see the costs, and here we see the net returns. The decision tree in the use, it has its advantages and disadvantages. So the advantage is that it's easy to read. It's some kind of visual representation of the decisions, of the possible outcomes. So once you learn how to read it, it's quite easy to read. It helps you identify which option is better based on the net return that you get. So that's great. I mean, it's pretty straightforward. It forces the managers to consider not only the possible financial outcomes from a decision, but also the likely chances of success and failure. So that's good. It's somehow taking into consideration probability. And lastly, the calculation of expected monetary values is a good starting point for the quantitative assessment of different options. So basically, you first start with the decision tree. You get a basic idea of which option might be the best, and then you dig deeper and do more focused quantitative assessment of the different options. Now, the disadvantages is that the more outcomes of the decisions there are, the messier and harder to read the diagram is. Okay, so before in the diagram I was showing you there were only two options and only two, let's say, outcomes, either poor weather or fine weather. But if I have more outcomes, more decisions, then the decision tree is going to have a lot more branches that we might need to read, and we might need to orient or yeah, basically get our get through more information to get through. The probabilities of events occurring may be based on past data, but circumstances may change. So this is going to be a disadvantage of most of the tools that we are using. It's going to be as useful as the data itself. If you're basing the future on past data, there's always going to be the risk that the past data is not going to reflect the future very well. The model is only as accurate as the data used, so that one I kind of mentioned, and it doesn't take into consideration the qualitative factors of a decision. So it only calculates the financial risks and the financial returns, but it does not consider, I don't know, let's say the motivation of employees or the reputation of the business and so on. The expected values are average returns. So that is actually a disadvantage because when we are looking here, the expected value, it is only an average of the values that we could either be getting. Yeah, we could have also gotten 4,000, and that is actually much less than let's say the 5,000, 7,000 here. So here it's again working with averages, and basically that's a disadvantage on its own. Okay, now would be great time to look at some specific example and try to work through it together. All right, let's read the case study. Expansion decision. The owner of a service station is planning to expand the business. The two options are to build a forecourt to sell petrol or to construct a showroom to sell cars. The estimated building costs are petrol forecourt, $100,000, and a car showroom, $150,000. The forecast economic consequences or payoffs during the expected lives of these investments will depend on the level of demand in the economy, as shown in the table below. The probability of demand being low during the lifespan of these investments is 0.2, and the probability of high demand is 0.8. Then the table shows you the economic returns from the two options. Now, our task is to construct a fully labeled decision tree diagram to show the options facing the garage owner and include on your diagram the payoffs and probabilities of each option. Okay, so let's get started. First, we have all the information in the case study, which is great. And we start by constructing the decision node, the decision point. This is where we draw the two options that the manager has. So one of the options is to build a petrol station. The other one is to build a showroom. Okay, so here it's very important that you draw the square. I'm stressing it out because a lot of students make a mistake here. Now, what else do we have? What else do we know? We have information about the costs of the projects. Okay, so the petrol station is going to cost $100,000. Since it's a cost, we can put it in brackets. A lot of the times we put things in brackets instead of a minus. And business and showroom is 150,000. Good. Now, what do we do next? We can show the different let's say events happening. So because it depends on probability, here we need to draw the chance nodes, the circles. Again, from each chance node, there are two events that can happen. It can either be high demand or they can be low demand. So in case there's high demand, the probability is going to be 0.8. In case it has low demand, the probability will be 0.2. So we write that all of that down. Now, what else? Once we have the events nicely labeled, the probabilities written, what do we do? What do we do next? So we can actually extended lines and draw the economic returns from the two options. Now we've constructed the decision tree. It has all the information that we need. We've worked from left to right, and that is the question worth 6 points. Now the second question asks us to calculate the expected value of both investments and recommend which option should be taken. Now that is going to be worth 4 points, and this is the second step where we actually work from right to left. So how do we do that? I'm going to take a different colored pencil or pen, and we're going to work from right to left. So how do we do that? 500,000 times 0.8, the probability, gives us a result of $400,000, and we just write it there for now, and we do that for each branch. Okay. Now, once we have the results for each chance node, we add them together and we write it down in front of the chance node. So now we know that the expected value of building the petrol forecourt will be $480,000. Great. So now we can actually go further, do the same thing for the car showroom. So we will have 800,000 times 0.8, which is 640,000, and the bottom one, the result will be $40,000. Now, if we add that together again, that gives us $680,000, and that is the expected value of building the car showroom. Now, we could go even further to calculate the net return of the two options. So for that, we need to just deduct the costs of the projects from the expected value. So in case for the petrol station, so it's going to be $480,000 minus $100,000. That's $380. For the showroom, it's going to be $680,000 minus 150,000, which is $530,000. Now we write it down at the very end, and since one of them is higher, that one is the option that we should take. And the option that we do not take, we actually cross with 2 lines. And that's how we indicate that we are not choosing that particular option.